Welcome back to Easy Astronomy. Glad you're here. Today I was looking at an article called Follow-up Observations of Particular Dusty Objects Close to Sagittarius A over in Astronomy and Astrophysics, and I just wanted to share some highlights from the article with you. We're going to head right into the heart of the Milky Way today. It's a place of extremes. We know there's a supermassive black hole there called Sagittarius A. And there's a lot of tightly packed stars that dance in a cosmic ballet around Sagittarius A. Astronomers have just published, through this article, new observations that close a decades-long gap in our monitoring of some of the most unusual objects orbiting the galactic core. At the center of our galaxy, like I mentioned, lies Sagittarius A. It's a supermassive black hole, millions of times more massive than our sun. And our sun's big. This is bigger, a lot bigger. Surrounding it is known as the S cluster, a population of fast-moving stars and a group of strange dusty objects called G sources. These dusty objects have puzzled astronomers for years. They just haven't been able to figure out what they are. Are they stars wrapped in dust? Are they stellar remnants? Or are they something entirely different? To crack the mystery, researchers turned to a powerful new tool, ERAS, an advanced instrument on the Very Large Telescope. ERAS builds on nearly 2 decades of earlier observations from instruments like NACO and Symphony, probably massacring those names, that's okay. I've always massacred things throughout my whole life, so I'm not going to stop now at 60. Anyway, these help astronomers bridge a crucial gap in observational coverage from 2019 to 2024. The team followed several standard dusty objects named G2, DSO, D9, X7, and X3, tracking how they moved and evolved as they orbit around Sagittarius A. G2 DSO, once thought to be possibly just a cloud of gas and dust, this object is still intact. It hasn't dissipated. The new data shows it continues on a very stable and a very predictable orbit, with no signs of being torn apart by the black hole's gravity. That suggests that G2 DSO may actually be a star embedded in dust, not a cloud being shredded apart. So, very likely possibility it's a star. Could be massive, that's put off a cloud of dust around it. Could be forming. Could be a newer star that's still kind of mitigated by dust. But it's probably not an interstellar gas cloud that's being shredded apart by the black hole. D9 is a dusty source, was confirmed to be a binary system, 2 stars orbiting each other, and its position and motion match predictions very closely, confirming that object is a binary star system. X7 was known for its distinctive shape and bow shock appearance. X7 was found to be faithfully following its Capellarian orbit, again showing no dramatic distribution by Sagittarius A. X3, more distant from the cluster core, but still kind of interesting. This massive young stellar object shows strong stellar outflows, evidence of dynamic processes much closer to the black hole. The results are striking, not just because of what was seen, but for what wasn't. These dusty objects don't appear to be getting shredded or destroyed by Sagittarius A, and the tidal forces related to Sagittarius A. Instead, they behave much like regular stars or stellar systems tightly orbiting a supermassive object. This challenges the early ideas that such dusty objects near Sagittarius A must be on the brink of destruction. These objects continue in a very stable and predictable orbit, and they continue to do what they do, and they're not being torn apart by the tidal forces of Sagittarius A, which is extremely interesting. So in essence, this study brings us closer than ever before to understanding the diverse cast of characters that are near the galaxy's core and near that central black hole, Sagittarius A. From the mysterious dusty sources to binary star systems, it highlights how powerful long-term observation campaigns are unraveling cosmic puzzles. It also gives us evidence of why we need to continue to study these things. Through long-term studies, we're able to actually get enough data to make the the right guess and come up with the right solution to what these objects are. And that just increases our knowledge. It increases what we know about our universe, and that benefits us all, because usually through the process of the studying and the things we find, we're able to increase our own capacity and our own knowledge. And anytime we do that, that knowledge probably down the road can be used for something else. Hope you have clear skies where you are. Hope you have clear skies in your personal life. Keep looking up. Thanks for joining Easy Astronomy until we come back and share something else with you from the wonderful wonders of our universe.